Most of the time, space missions follow carefully planned paths that never cross anything unexpected. Every now and then, though, the timing lines up in a way no one could have predicted. That is what's happening with 3I Atlas. It's an object that slipped in from outside the solar system, and by coincidence, two spacecraft already cruising through their own routines now find themselves in just the right place to catch some of its material. It's not the kind of chance you plan for. Europa Clipper is on its long path toward Jupiter, and Hera is settling into its mission around the Didymos system. Neither was built to chase interstellar visitors. Yet their current positions make it possible for them to pass through the thin, stretched-out trail of particles that 3I Atlas is leaving behind. This isn't about dramatic encounters or close flybys. It's about using instruments already running to take a quiet look at dust and ions that were born around another star. If the geometry holds, both missions could gather tiny clues about what kinds of materials drift between planetary systems. That's rare. When interstellar objects show up, they move fast and stay within range for only a short time. So when two spacecraft happen to be aligned with one at the same moment, it opens a small window to study something that doesn't belong to our solar system at all. Let's look at the two spacecraft that are key to this alignment. First up is Europa Clipper, a mission by NASA launched in October 2024 to explore Europa, one of the icy moons of Jupiter. Its main goal is to investigate whether Europa's subsurface ocean might be a suitable environment for life. NASA Science +1. It carries 9 scientific instruments designed to study ice thickness, composition, ocean depth, and other clues. NASA Science. The second is Hera, a mission by European Space Agency, ESA, launched around the same time. Hera's primary aim is to inspect the binary asteroid system of Dimorphos and Didymos, which was struck by NASA's DART spacecraft, to learn more about asteroid physics and planetary defense techniques. Wikipedia +1. What makes these two especially interesting in the context of 3I Atlas is their position and trajectory within the solar system. While their primary missions are not tied to interstellar objects, their orbits and timing happen to place them in favorable geometry relative to 3I Atlas's path and tail. In other words, they are in the right place at the right time for a chance to sample or at least observe material associated with an interstellar visitor. Their instrumentation also helps. Instruments designed to detect dust, charged particles, imaging, and spectrometry could pick up faint traces of non-solar system material if the alignment holds. So, while they weren't built for this specific interstellar chance, they are equipped well enough to take advantage. I Atlas didn't swing through the inner solar system in a neat, predictable arc. Its path is steep, fast, and angled in a way that only an object from outside our system can manage. As it moves, sunlight pushes gas and dust off its surface and stretches the material into a long, thin tail. That tail covers far more space than the nucleus ever will, which is what turns this moment into an opportunity. Europa Clipper and Hera aren't anywhere near the comet's core. They don't need to be. What matters is that both spacecraft are cruising through regions that the ion tail will pass through as it drifts and bends under the solar wind. The particles in that tail are incredibly sparse, but sensitive instruments can still notice changes in charged particles or dust composition when they pass through it. The timing is what surprises mission teams. Neither spacecraft is changing course for this. They simply intersect the right regions at the right time, while 3I Atlas moves along its own trajectory. It's the kind of alignment that lasts only briefly before the comet races back into the dark. If everything lines up, each spacecraft could register subtle shifts in the environment as they enter the tail's outer edges. Even a faint signature would carry information about material that formed around another star. That's rare data, especially for missions that were never designed to collect it. The moment won't be dramatic from the spacecraft's point of view. They won't see anything or feel anything. But the instruments running quietly in the background could be recording traces of an object that has traveled for millions of years to get here. Most of what we know about interstellar objects comes from brief telescope observations. They rush past the sun, and by the time we figure out what they're made of, they're already fading from view. Having two spacecraft inside the tail of one gives scientists a different kind of information. Instead of light bouncing off the object, we get direct measurements of the particles that drift away from it. Those particles can reveal how the object formed. Dust grains carry fingerprints of their original environment. Their mix of elements, their size, and even how they hold electrical charge all point to the kind of star and disk they came from. If Europa Clipper or Hera registers anything unusual, it could help compare our solar system's building blocks with those from somewhere else. There's also the question of how material survives long journeys between stars. Interstellar space is not gentle. Radiation, collisions with tiny grains, and long exposure to cosmic rays all reshape the surface of an object. By studying any altered particles that reach these spacecraft, scientists can learn how much an interstellar traveler changes on the way in. Even a weak signal matters. It helps refine models of how often these visitors arrive, how their tails behave near the sun, and how far their dust spreads, that in turn prepares us for future cases where missions might be able to respond more deliberately. The most interesting part is that we're learning from a coincidence. Two spacecraft with completely different goals are about to help answer questions about worlds beyond our own star. That's a rare kind of scientific bonus, and it doesn't happen often. Moments like this remind us that exploration isn't always about chasing a target. Sometimes a quiet coincidence offers a glimpse into a place we could never reach on purpose. Europa Clipper and Hera were built to study oceans and asteroids, not visitors from another star, yet their paths have set them up to catch the faintest traces of 3I Atlas. If their instruments register anything unusual, it will give us a small link between our solar system and whatever distant region this object came from. Even if the signals are light, they help build a more complete picture of how material moves between stars and how often events like this might happen. It's a modest moment, but it marks another step in understanding how our solar system fits into the larger galaxy, and it came from being ready to notice something unexpected.